All right. Hey, Jeff, thanks so much for joining the Coding with Callie meetup as our guest speaker. You can go ahead and take over whenever you're ready.
I will share my slides.
And then, Jeff, do you like questions while you're presenting, or do you want people to wait with questions to the end?
So I prefer if people have questions to jump in whenever. Uh, if it is a question I'm going to answer on the next slide, I will stop you and let you know that. Don't
Okay,
worry. So ask away. If you'd like to follow along with the slides, they're available at that URL. Um, and I will post them on my personal site on as well after this.
awesome. Thanks.
So what I like to always do is go through an agenda. Uh, this is the rough outline of what we're going to cover. If this doesn't sound good to you, let me know. We can see about adjustments since it's a meetup. It's always fun. I'll start the brief who I am. We'll go through the definitions. When it comes to health checks, there's lots of different terminology floating around. So we're just going to ground set so we kind of all speak the same language. We're then going to go into the mental model of health checks. Um, what are the properties of a health check? We'll do a little bit of a demo, and we're going to use the book crud Nest.js. Took a little riff on that so we can look at what health checks look like in there. Uh, we'll come back and talk about what are health checks good for, and kind of dig into some different cases there, and then we can briefly touch on some health check patterns from there.
Nice. Sounds great.
So I'm Jeff. I'm BeckJ01 on most platforms. If you find a platform I'm not that on, let me know and I'll probably sign up just to squat the name. Uh, so if you want to know more about me, the jeffbeck.io has more ramblings about myself, but that makes me uncomfortable. So we're going to just keep pushing forward. Uh, I do like to give a warning. I would consider this a work in progress. This is the first time through this particular presentation. So give me feedback on the flow, the materials, things you don't like. The other thing is I have no idea, given the audience, what terms you know and what you don't know. So stop me and ask questions, um, especially if it's a term that you feel like everyone knows, because if you don't know it, someone else doesn't know it, and it should have ended up in the definitions earlier in the presentation. Thus, it's especially important, given this is the first run through, if you hear terms you don't know, let me know. And I am not seeing the chat, so if anyone does do the chat, make
I can
sure,
interrupt you. Yeah.
yeah, that'd be perfect. All right, I think I got the chat up now. So the main three definitions we're going to start by setting is health check. That's an action that confirms some bit of functionality. Heartbeat is a message sent out. It is something that gets pushed out. And then health check endpoint is where you're going to actually read the state of health checks. So that's where those are the kind of three distinctions we're going to start with. And then we have deep versus shallow health checks. This is a term that you're going to see a lot in AWS documentation. It floats around elsewhere. Uh, deep is going to check off box dependencies. So that's where you're calling out to a database or you're calling out to some other system. Uh, shallow health checks are just the box itself. So like your service, maybe the memory, maybe the disk, just whatever that one box has. When you're reasoning about deep versus shallow, you'll see people talk about what's good to use where. We'll get into that later in the presentation, but the big idea here is understand that there is a very big difference between checking your own dependencies and checking just your own box. Heartbeat versus health check. Now, this has come up a few times, so I wanted to make sure we dug into it. A heartbeat is pushed out of the microservice. it is something that's pushed out over some channel, so it's outbound. I always like to think of heartbeats as outbound and health checks as an inbound read. So the health check endpoint that you're exposing, something is reading it. And so you can think of these as directional. The other thing is heart cases are use case specific. So if you have, let's say a RabbitMQ channel, you may keep the driver itself may keep a heartbeat between the client and the server to keep alive, keep that connection open. The other thing that will happen is heartbeats will many times include the payload that is protected information, like uh, version and oh, this is my client ID and there's extra stuff you can put into a heartbeat. They are typically very lightweight. And Morgan has added some nice comments in the chat if that I would agree with. Uh, Before we move on from definitions, any questions about the high level so far? I will take awkward silence to move on. Uh, I typically, when we're in person, I'll call on people. Now, mental model. The thing to remember about a health check, to me, this is the most important thing, is that it represents a single instance. So when you're doing health checks or reading a health check endpoint, it is not your entire application. It's not everything. It is this one single instance. So you'll see one red instance. That's all you're really going to get when you read a health check. Because if you're using a load balancer and you're doing, let's say, HTTP health check, it's going to call, it's going to route to a single instance. You're reading that one thing. It also means a shared set of nodes with a shared dependency can all go unhealthy at once. And so when you are reading the states of health checks, the thing to think about is I'm going to design a health check, make sure like if this link between this region and this database goes down, all of these are going to go red. They're all going to drop. And that's maybe desirable, but something to think about. And then you're always going to reason about that when you're designing for your health checks. And then, of course, the final state is if your database goes down and you're health checking against your database, everything fails at once in your health check. Each one that you read will be read, but they are all read at once. And that's something to understand, that you are always thinking about individuals and then aggregating together. So that once you have the basics in your mental model and as you work through it, we can then think about what are the properties of health check. So remember, we split health check and health check endpoint. So right now we're talking about an individual health check. It's going to check a single condition, like I can read from the database, or I can write from the database, or I have a database connection. Those could all be 3 health checks. It could be 1 health check. The one condition that you're checking might be like, I need these 3 properties to be true, and that's the one condition, but still a health check is going to represent itself as true or false. So thus it's one condition, even if it's an aggregate, a composite, it's still one output.
When would you do like all three of those in one condition versus 3 separate health checks?
Yeah, so it usually is a property of what you're checking. So if I'm checking a database, I will almost always be checking that I have a connection, and I won't be checking for write and things like that because I expect that writes are that like if my connection works, it works. Like I have debugged,
Okay.
I'm not doing a health check for that. Whereas I might check that my basics, like I might check that that my file system isn't full, because I know if my file system is full, nothing works ever. Um, so I would check that plus potentially like a network stack ping and maybe an OS version. Might check all of those together and call that one state like basic health. And like I never care. Like if any of those 3 things are broken, I don't care about the details. So I'm not trying to reason about it in separate ways. Whenever possible, though, you want to be reflecting the state of health, not checking the health. And this is what gets really confusing. If you are actively doing something as part of the health check, that's not as ideal as reading the real state. So if you are using, let's, for example, say a circuit breaker pattern, um, it's better to reflect the state of the circuits being closed or open being unhealthy than it is to actively call the method that would actually try to use the circuit breaker. And so in this case, you're always reflecting the state of the world, not actively doing it. And that's when possible. That's not always possible in a health check, but that has uh, further implications that we can get to later. The other, the other item is no side effects. Now, when I say side effects, I mean the supercomputer sciencey side effects. So, like, if you call a health check, it shouldn't change like the running state of your application. If you do, you're gonna have problems down the line. I will say all rules are meant to be broken at some point. I have not found a situation to break this rule in. If someone finds it, please message me in whatever tool you want. I would be love to hear it. I'm super curious. And then the most important item is the hardest to put into words. A health check has to represent value for a given service. And I mean value as in has to be something useful. If your service never writes to disk and you're checking an attached volumes like like disk size and alerting that it's 80% full that you don't ever write to it, it doesn't matter. It's not valuable. I say that given that that is a very default health check that, hey, anytime I get above 80%, I want to alert on. And yeah, Morgan's calling out, yeah, if log rate is broken. I'm specifically saying if you never write there. So there are times where you might attach a disk that you're only ever reading from, and that you're doing a shared disk, a NAS situation, some weird EFS hack. Those are the situations where you probably don't want to do a health check against the health of that system because it's not managed by your app. You're managing it elsewhere. And so that's a great place to actually push that off to somewhere else. So that's the health checks. Now, a health check endpoint, there's some special notes to understand about it. 99% of the time, your health check endpoint, yeah, that was right. Your health check endpoint is unauthenticated. So you need to understand that
When would it be authenticated?
you are doing something very special that you've decided to make it authenticated and you have something that can check the health that's in an authenticated way. I don't know when you would do that, is the real answer.
Okay.
Uh, is it possible that you do it? Yes. I don't know that you want to. But the consideration then is this is an unauthenticated endpoint. So the second item, you must not generate load with repeated calls. That the reason for that is if you have an unauthenticated endpoint, you are now, let's just assume someone bypasses your WAF or you don't have a WAF because who starts with a WAF? I don't, even though I should. This is where you don't want to generate any load. And so when I talk about the health check itself reflecting state, not going to actively check the state, this is where you would do that. And then if you do need to have the health check actually go and like, hey, I'm going to go check something, you can layer a cache in at your health check endpoint and say, oh, I'm going to do a read through cache with a 5-second TTL or something. Thus, you know, every call won't generate load. There's a cache in front of it that will help. Typically, I would do an on box cache, not 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 like a shared cache. You could do a shared cache off box, but then you get a weird dependency that you're probably generating load on. You also must represent if the service can do work or not. This is where you are making decisions about all the health checks that you did. You may have done health checks that say, hey, this cache is not alive, it's unhealthy. But it's okay because I'm okay just not hitting the database and not doing my cache. And so you may consider your health, the health of the endpoint healthy, but still show, hey, I have a cache problem. It's we're degraded. And this is where you're making those choices, is your health check endpoint typically. And you're aggregating here all of the health checks of the microservice that you care about and reason about into one place. So this is where you've moved from that singular into, for that instance, all of the aggregates. Now, what that mean is other explicit callouts. Don't share sensitive details. This is unauthenticated. If you tell me your database version or your client version, I will go and check, like, to see if there's 0 days. I'm going to go learn more about your system. Like, don't expose secure details here. Definitely don't dump stack traces. So how do you do that? Is how does it work in your system? How do you securely do debugging? I personally like to generate a log ID that is then in my logging that I can go search for. But the UUID or GUID or whatever I've tossed on screen is secure and it doesn't expose extra detail. Again, reflect the state. Don't go check it. This is the case where you should be reading from local caches. You should be checking the states of things. The other thing is you're going to get called a lot. Even in the best circumstances, this endpoint is going to be very high traffic. And the more aggressive you get with trying to make sure things are healthy elsewhere, the more pressure you're going to put on this endpoint. You're going to depend a lot on the properties of the health checks themselves that this endpoint is safe. If you have a health check that is writing to your database and every time it gets called and you're hammering your database from your health check, you generate a lot of load for no reason. The logic of understanding if you're healthy or not is typically done here as well. So this is what I said. You're reasoning about as a whole, am I healthy? Am I not? What do I do? How does that, any questions so far?
I kind of have a question about what Morgan is posting in the chat. Is that
Oh,
Yes. No,
okay?
yeah, do it. So ask your question and then we'll talk about that.
Okay, so this is a good endpoint to do metrics instead of logging. So, Morgan, are you saying like a counter for how many times like the health check is like healthy versus not healthy
yeah,
metric, and then a
totally.
marker for going off if it count goes down or something?
Yeah. So in a system, in like a big Kubernetes deployment, for example, you might have a health check per pod across 1,000 pods. And I have seen systems where 40 to 60% of the logging, and these are people who are spending, $100,000 a month on their like logging bill. Um, is all just logs from like the health check. And if you can like emit metrics for that instead of logging those, um, you can say it's just like a lot more efficient because really we just care about, up or down for the most part. If it's a more sophisticated health check where like Jeff was talking about where there's database results and stuff, you might
I
want to like do something different, but like in
no,
general, a basic health check I like metrics for.
I'll go farther. You should not be doing access logging because the particular what the one
Preach.
the case that you are talking about where you're gonna have thousands of calls checking ready and live, that if you have access logging turned on your web framework that's just generically on, you will not get any use out of access logging to your health endpoints. You shouldn't log there because it's just going to waste your disk. In the case of like the body of it, you shouldn't be logging the outbound body of your websites most of the time anyway. That's a very weird special case that usually means you've done something wrong in observability. That is a way easier way to address it, not this talk. So don't, uh, in those cases though, you don't only have to depend on a REST endpoint to get this. You can emit your health checks as metrics themselves. So instead of thinking about only when I'm called do I emit a metric, you can actually just emit
Oh, I like
instead of
that.
you can emit these things as metrics. That's a more we will get to some advanced cases of it when debugging of how you have to reason about it, but I will foreshadow that you have to reason about how you're logging, how you're graphing it, because you care a lot more about individual things being down, because a single zero versus a one, which is typically how a Boolean is represented, matters a lot more than an aggregate average across the cluster. Uh, but we can get into that
Would that be more of
later.
a heartbeat then if you're
Nope. So the metrics, depending on how you're doing your metrics, uh,
okay?
you're almost unless you're there are metrics that you push out. Most of them are read. Things like Prometheus, things like that, they're reading. In general, your heartbeat's going to be really, really simple. I'm alive over a known channel, and it's use case specific. Whereas in the case of emanating metrics, you're still like you might be pushing them out, but they're usually read into a system.
Okay.
So it's this case where, depending on how you're delivering the metrics and the metric system, if you're using Datadog versus Prometheus versus whatever else, those things tend to flip around how you pull the metrics, but
Okay.
how they're read and interacted with is still considered like you're reading from it. It's not being pushed out. The other thing I will say is a heartbeat is almost always acted on by one system, not many systems. So a heartbeat is almost always one system is listening for that heartbeat and going to act on it. Whereas in the case of metrics of a health check, many systems might be acting on it. Morgan, what's your question
Yeah, and
or
that's the other
comment?
thing too is like how is it implemented? Because you know, you could consider it a heartbeat if I have a background thread that emits a metric every, you know, X amount of seconds saying
That's
I'm
what I
up.
was thinking. Yeah.
But if you have a metric it on the endpoint and you're just emitting like a, you know, your distribution metrics for that endpoint or status codes or whatever, then that is like a health check. So like some of this
It,
is a little semantic too, I think.
Okay.
yep. And for our discussion, we'll consider a heartbeat to be that point to point channel, whereas any delivery mechanism of the health would be an advanced health would be a health check. All right. So that's what it means for you. So now we are going to try a live-ish demo. Live-ish is in it's a live demo, but I'm not going to be live coding because I don't do that because I never do that well. So if you would like to follow along, this is the link for that. I can post it in the chat quick. There is
Also, I'm sorry that the book card is not finished. Don't know if that was necessary at all.
doesn't matter if it's finished or not. Hopefully I'm not sharing something you didn't want shared though.
Oh, no, it doesn't matter. I just live code for fun. It doesn't really matter where it ends up.
So we are going to now share my VS Code. Let me know if everyone can see it.
Yes.
All right, we're going to move stuff around so I'm not staring off screen. So what we actually have here is using what is called Terminus, part of the Nest framework. So the Nest.js framework. This is the kind of typical health checks. They're very similar to what we would have. Right now, I have it running. I added an extra API just so we could make these calls. And this comes up with two different health checks right now. And so this health check is a database. And see, you're saying database, it's the type ORM health indicator. And so in Terminus, they use the term indicator for the different health checks
Mm,
themselves. And type ORM is what was in this project. And
yes.
so built into type ORM and Terminus is the ability to do what's called a ping check. So that's a very normal database operation to check whether or not your connection pool and everything is healthy. And so as long as it's healthy, it's going to return true. And then I also set up this ping check, an HTTP ping check. And so it's going to check for a 200 health code against this other service that's running. And
So
so that
this
other API.
API is hitting the other API,
Yep.
the actual book CRUD API's health endpoint, and also hitting the book CRUD's database.
So book CRUD is running on port 3000. So let's go ahead and make a request. And you will now see that another API, which is this other API I have running over here, is up. It's running. And we have everything working. Now, these are our two things running, but let's jump over and start messing with it a little bit. So we'll clear that. And what we're going to do is we're going to watch the health endpoint with a curl and a JQ. And so every 10th of a second, I think I set it to, I don't know, I set it to something. It is calling your health endpoint. And now if we go and pause the Docker container that's running our database, you'll now see that it's not working anymore. So we paused our database. The health endpoint is doing all this work, and this is the what you're seeing, what it looks like. And I'm running this through JQ is why it's looking all pretty instead of just straight curl. But if we want to bring it back, we can just unpause our Docker image of our database, and you'll notice everything's immediately back up. Now that looks fancy and good, but it should give you a little bit of pause. And the reason it should give you a little bit of pause is that was almost instantaneous, which means it's likely not reflecting the state because the only work going on is this health check call. But so that's something. Now, let's say we can do work. In this case, we know we can always do our work as long as we have a database. But if we were to flip over and terminate our, so I turned off another API. It's now down. The overall status is error. Another API is giving us why it's down. It's connection refused. And you'll notice if we look over here, this is just scrolling constantly because it's actively checking every time we make the call. And so that's every one of those calls is generating load. That's just how Terminus works. But so if we want to fix that, we can bring the API back up, and then we go back over here, and you'll notice everything is now back up. Questions about that so far?
Can you explain more why you were saying like that this should give us pause because it's just checking if it's up? Can you explain more?
Because it is actively checking every time we call the health check a Terminus health check by default, right as it's set up. Oh, this is another API. This one by default is doing work. So if we go and actually like look at the code, we'll notice that it is just actively making that callback. And so that, like I said, this is something that if I was writing in a language I knew, I would wrap this in a cache. And I will be honest, and I ran out of time. So I didn't do it on this one. If it was Java, I would use caffeine and use an in-memory cache and set it to like a second so that it would every call would only call this other API once a second. And so wrapping your async call in something that's caching would be the way to go to make sure you're not constantly doing that work and generating that load.
Can you not set like a time for like how is that getting called right now? Like, is it
So,
not on some sort of timer?
it is, and I control the timer from the outside. So this is where you have to, the division of control is really important here. If
Okay.
this is an unauthenticated endpoint, you don't control how often people call you. and it's
Oh, okay.
and it's an unauthenticated endpoint. And so if I choose to call people really fast, like I do, because I'm a programmer and this is the type of thing I would do against my own API just to see how it's doing, I would run watch at 0.1 seconds and just hammer it. And like, there's a good chance, knowing me, I would forget which tab this was in my TMUX session, open a new TMUX session, set the same thing up, and have 5 or 6 of them going before I realize what I did, because that is the kind of programmer I am. So
Okay,
I tend to litter things everywhere. This is where, in some health check frameworks, not in Terminus, but in some health check frameworks, you do set how often to do this call instead. And so that's what you would do if you were to wrap this in a cache. You could do that. Now, let's make this slightly better though. So right now we know that if we say, hey, I'm calling another API here as like an extra thing, I don't have to do that and I can still like do my service contract. So let's go and see what I would do to make that work. So we'll check out a different branch that has now set up, and like I'm pretty sure cancel. I'm pretty sure I didn't set it up correctly to refresh. So I'm going to just run that while we talk about the code. So now we have our normal health check that we had before, and only our database is in this. And then I moved down to this new path called ready, another API. And this is where I could potentially split something called liveliness versus readiness. And we can talk about that next. And we'll get into what that looks like and why shortly. But this is what helps us go through and split it apart. So let's look at what these look like. We now have a basic health check request. Everything is up. It looks good. We're still green. And we only have one check. If we do this new health ready endpoint to 3000, you'll notice that we have more data. Now, if we were to go and do the health check directly against another API, you'll notice that what another API is doing is health checking that Google works, because I don't know why it's decided to do that, but it did. But now if we were to kill that API, you'll notice that we get an error down here. That's just what happens with this particular plugin that I'm using to visualize things. But if we do our health check to the basic of your book CRUD, everything's working, everything's up. But now if I do the ready check, you'll notice that I get an error here. And you'll also see that our status code is 503. And that's important later in the talk of why that status code matters. So that's the rough how things are going to work. And if you would like to play with any of this, it is all in GitHub under the health tag and the health next tag are the two tags I did. And then there's also a dev container set up and a health HTTP scratch pad in there, because I don't do Node normally. And so I just used a Docker container for everything. So everything's there. If you want to use it, feel free.
Nice. I'll share it with the Coding with Callie Slack workspace too.
Yep. And is there any questions before I close this that people would like to see? Morgan's muted if you were talking. All right. I will then get back to sharing the presentation. So now we kind of know how you would build one. And we've talked about the mental model you want to use. The big question left, though, is Oh, sorry. There's also all of these links. I want to make sure we look at one last one, which I thought was super interesting. Before we move on from the demo. Health check recipes for Next.js is just the documentation. The samples are really good. Check out the samples. But the example fix is what I was talking about earlier. So this is a change that was made by someone in the actual Terminus project. And what they have done is they've moved the Mongo connection used to actually go and make a new Mongo connection every time it did a health check, which is incredibly expensive. And so the fix is to actually just use the database connection pool and do this ping. You'll notice, I will say, I said don't do active checks. Database pools with things like ping one and select query are so specialized that you can probably get away with it and it'll be okay. There are better ways, but they've done a lot of work because this pattern is so common. And it also does the double-edged duty of keeping your database connections like from all being reaped, which is bad. It basically means you're using your health check to keep your connections alive, and that's a state change. That's like side effects. It's a really hard thing to reason about if that's what you're doing, but it happens. But this is link is in there, so if you're interested, you can look at the actual change, which I think is super fun. This is also why I love like GitHub and open source, is because I can go and see the actual changes made. And then when you get a similar thing in your own health check, you can be like, oh, I saw someone that fixed this. I just have to do a similar pattern, which I do. A lot of my open source contributions have been like, oh, we need to do the same thing this other people already figured out. So now we kind of have a rough idea what a health check is, how to make one. What are they good for? Four things. And now you're going to see where, hey, I said this was the first pass through it. I need a better name here. So if someone knows the either industry correct name or has just a better name for instance lifecycle, let me know afterwards. So we can use health checks for traffic routing, deployments, instance lifecycle, which I'll get into what that means, or debugging. So Kubernetes example. Kubernetes has 3 major probes that are all health checks. They have a liveliness probe, a readiness probe, and a startup probe. Go ahead and jump into the Kubernetes documentation for more details. But the liveliness probe is what fulfills our life cycle and deployment work. So when I said there was like, here are the things it's good for, the liveliness probe is actually going to be used for both deployment and lifecycle. I would almost always use a simple HTTP probe, but that's because I think REST is my golden hammer for all problems. In general, you're going to set it up in a very easy way. You have the liveliness probe right here. You are saying the path, the port, and things like the period seconds. Callie, as you asked earlier, hey, how often is this getting called? Again, this is external. So you're going to set it up here of how often your Kubernetes is going to call this pod. Any time that you have a failure and you emanate that 503 status that we saw in our health check earlier, yeah, it's going to terminate the pod. So this is going to terminate the pod and allow it to get replaced, or it's not going. And so that's why it's part of deployment and lifecycle, because it's not live yet. It won't put it into the live state. And its life cycle is, I'm trying to talk about when you terminate things or keep them alive. So this is what it will look like for a pod definition to actually set up your liveliness probe. I would almost always use that simple terminus endpoint that we made earlier. Because remember how I split it out into 2 in the health next. That was the normal one and a ready one. I use the ready name because of the readiness probe in Kubernetes. And this is for traffic. This is where when you're ready to accept traffic, your readiness probe should be green. It should be 200. I would almost always set this personally. I like to set this as either a separate endpoint or use a query parameter to that same endpoint to switch the behavior of
Oh, that's
if you're
clever.
doing ready or not. The reason you might want to do that is if you are uncomfortable with the amount of unauthenticated endpoints you are allowing in, and you're like, I'm very specifically only letting one in, query parameters will let you kind of adjust how you react to it. So that way you can reuse pretty much all of the config that you did here, except it's going to say readiness probe. And then if you're adding a path, you're changing the path right here. But otherwise, it's the same config and it acts very similar. It's just whether or not you're accepting traffic there. The last item is a startup probe. This is the really interesting special case. It is effectively a way to turn off the readiness and liveness probes in Kubernetes and just care about deployment. So don't do anything to do with traffic routing or lifecycle, just care about deployment. And so once a startup probe goes green, like it gets a 200, it's good to go, it no longer runs again. And so this is checked at startup, and then once it's done, readiness and liveness probes are the only ones. So that's another reason, again, to use something like a query param in that same thing to say, hey, this is what we should do. Now, it's going to, it has some different timeouts and like how long you should try until it's completely failed. Things like that are all going to be a little different. And so you can set those differently for a startup probe versus there. Now, why are you doing this? Basically, you can do it to address three major areas. Cold start. So if you're using a JVM and you aren't doing like a native image of the JVM, which you can do now if you don't want cold start or you're doing Lambdas, go do a fancy Graal VM, like native VM. It's awesome. Do that. It's fast. But if you have cold start from other things, because you need to do prefetch caching, you can consider that cold start. You could say it's just something else you do. If you say, hey, my service is up, but I am going to go and read from like 3 or 4 services and like prefetch everything I need because I know they don't change, or hey, once I'm online, I get events that tell me when these things are stale, or I get the real-time events of what's going on, but I need to go fetch the like back catalog. You could do that. And then you can have those as health checks that only run during startup. And then you never use them again because there's no way for them to go bad. Probably. Depends how expensive that health check is. Maybe you want to keep it. The other thing is expensive security. This is if you are doing probably something weird with to like bidirectional security, or you're doing something special here that's not on every request. There is some cases where you may do that. I'm thinking in particular of like the voltage library in Java and does some enterprise encryption that has like a pretty hefty startup tax. Anything that's doing license calls, probably get those done first. So that's Kubernetes. Next, we're going to go to AWS. So if there's questions about Kubernetes and how we kind of work with these main probes. Silence is gold. All right. So AWS, on the other hand, is going to effectively split out this work. Instead of having those 3 probes that are all kind of the pod definition, AWS, for the most part, is going to split this off into, speaking of EC2 mostly here, if you're doing ECS or something, there's some differences. As you get to more esoteric services, we can get into those, but they're not as important because you're probably not using them. You have Elastic Load Balancer that is going to care about your traffic, and your autoscale groups is your lifecycle and your deployment. So your load balancers, there's lots of flavors of them, but they all support some form of health check, and it's only going to route traffic to healthy instances. In particular, what you care about, looking at the classic load balancers, is these are your levers that you adjust on your health check on their side. So we talked about in Kubernetes how often you're going to call, things like that. These are your 4 levers that you get to adjust on a classic load balancer. It's just how long to wait, how often to check, and then how many consecutive failures is unhealthy. So this is where you know how many times that endpoint has to fail to go away, and then how many times it has to be correct, like say, yep, I'm green, to be healthy again, to be get packed in to doing traffic. Here's what's really interesting. You have to reason about how responsive versus you want your health checks to be. So if you trust that your health check is emanating a lot of stuff very fast and it's safe to use, maybe you adjust some of these. By default, though, it's going to require two unhealthy checks in a row and only check every 30 seconds. So that means it's going to take a minute of downtime in the worst case for it to actually catch it. In the worst case, best case, I think is 31 seconds. Like it goes down right before a health check comes in at that 30-second mark. And then like, yeah, so it's 31 seconds is like best case scenario. Worst case scenario, you're down for a minute. Now, if that is fast enough for you, great. If it's not, though, there's also the fudge factor of response timeout. So like if you were trying to get this really tight and you have like a really long response timeout of like, for some reason, someone set it to 5 minutes, that immediately means you can't get unhealthy unless you wait 5 minutes. I don't even think it lets you do it that high. But the example is you need to reason about all of those together to think about how fast you're going to respond to in a healthy state. Because if it's a single instance that's unhealthy, the faster you get it out of the load balancer traffic pool, the faster your customers get better service. Next, we'll talk about the application load balancer. It has all of the same levers, except it's also added a matcher. The matcher allows you to have different status codes. So you don't have to just do a 200 status code. You can tell it what status code to look for. This is useful, but it also means you're probably trying to be clever. And I don't know that you want to be clever here. And this is like you constantly have to judge how clever do I want to be here versus do I just nuke and pave my entire stack and get something new in? And I almost always lean towards the nuke and pave, but that's me. I'm off. Let's see if this. All right. We'll have to do it over here because I messed up my other thing. I have a speaker deck over here and I messed it up somehow. So.
Oh, well, no one can notice.
So we have your auto scale groups. This is your life cycle for EC2 instances. It supports all of these health checks out of the box. I, for the life of me, can't tell you what VPC lattice is, but I have a link to the docs. EC2 health check and EBS health checks are useful in the sense of if they're bad, they're really bad, and you should terminate those instances. They're never going to get a false unhealthy there. But there's a lot of times that instance is not going to be working and its EC2 health check is going to be just fine. That happens a lot. And so the easy answer is to use your elastic load balancing health check. The problem with that is you're now tying your traffic to your life cycle. So this means if, for example, we go to this model and we have a database go down, it's going to terminate every single one of those red things. And that means if you have a cold start and it takes a long time to come back up, your total downtime is much higher than had you just taken things out of the work pool. Now, I will say I almost always set it up with this, and I will let things come back in. But if I realize I have the everything's red scenario, I will actually intervene with the ASG instead. And so that's where what I'll do is spend health checks and replace unhealthy. I will set an instance to standby. These things will stop the instances from being terminated. This is an ASG specific thing. but that allows us to really like intervene and stop what's going on, and allows potentially that other thing to go green and everything come back. So it stops termination, but things won't be taking traffic because the load balancers will still see them as unhealthy. Yeah.
Yeah, just to elaborate, because some people might not understand like the scenario we're in with something like this, but like, yeah, if basically latency becomes so high, if your system is overloaded, that the health check takes a really long time to respond, and then because that's happening, we start saying, oh, these are unhealthy instances, and you bring new ones in, but they're starting up. And when they're starting up, they're using a ton more CPU than they usually do. So it's like a cascading failure that just continues to cycle. So Jeff's saying like we stop getting rid of the boxes and then we keep them around so we can bring more in and then stuff will become healthy. Yeah.
Thank you. That was helpful.
That's that's one of my standards in incident. Turn off downscaling, turn off termination, double the boxes. Pray, ask for forgiveness from finance later.
True. It works. It works a lot of the time.
Yes, and reasoning about why it doesn't work is a much more interesting thing to do in a post-mortem than it is during 3 a.m. incidents. Other questions about AWS before we like touch on Azure?
No.
Okay.
From me.
Azure has what's called VMSS, which is virtual machine scale sets, and they have a very different naming of everything. So in particular, all of the principles we've talked about for ASGs hold true, but what you want to look for is things called automatic instance repair, because that's how they terminate boxes. No, it does not make sense to me either, but that's what you should be looking for. Realizing how much time we have left, I'm going to keep moving. We have debugging with health checks. So health checks are incredibly useful to debug with, but you need to understand that if you are doing a curl, you're doing it to one instance. You are checking one instance. So I will actually go on the machine and curl the health check from localhost to see how that instance is doing. If it's acting weird, I will pull the box out of traffic. I'll do that. I'll look at it individually. I almost always am looking in aggregate checks in metrics, not in individual health checks. I'm not going to the website or the URL as part of my like how is my fleet doing. If I'm doing fleet management, I'm looking in the aggregate of checks. Now the aggregate of checks is where you have to be careful of how you dashboard it, because if you dashboard it by default, most systems are going to average for you, or they're going to give you like, oh, it's the max of the last 5 minutes or like something like that. Max of the last 5 minutes is great if it's high watermarks that you're looking for. But what you're looking for is any instance of zero, because almost every metric that you push out that's a Boolean will be a 0 or a 1. In Datadog, a lot of systems, other systems might do Booleans better. So what you're looking for, though, is also what dimensions you want to slice on. If you have the money, if you can slice per instance, you can see exactly what it is. If you then also aggregate not per instance, but per region, and you see a bunch of unhealthy per a single region, that may be an indication that you have a regional failure. That regional failure looks something like this, where like the network link between region 1 and the database is down here. In that case, you could potentially go out of your way to just stop using that region. And what I mean by that is like if one thing is failing and then you see a second one failing, second microservice failing in that same region, you may want to stop all traffic to all microservices in that region and like evacuate the region, go elsewhere. How you're told to do that, no idea. But it's the kind of debugging and what you get out of health checks that as you aggregate this up, you can look at. As you reason about this in aggregate, though, remember how you read the health check and how live is the health check. So if you are caching, let's say for 5 minutes, because we're trying not to take everything down, that 5 minute lag, if you then build your health check to say, oh, I'm going to like not be very aggressive in my load balancer health check and I'm only going to check every 5 minutes, that now balloons out to 10. And so you have to have this aggregate view of what are my delays, what are my caches as you build up your health checks. You can't do everything immediate. Everything can't be instantaneous, but you have to understand how tight your tolerances are along the way before you start reasoning about it at the top level for debugging. I will say for debugging with health checks, I find it incredibly useful for single boxes, and I find it very useful in aggregate, not at the per instance level, but at the regional level and things like that. Quick set of health check patterns. So this is how I would actually implement my health checks. I would reflect the state of circuit breakers. We've talked about that a few times. Well, I've mentioned it a few times. I would call back to call some other health checks. Here be dragons. This is where you get cascading failures, but it's also incredibly useful. My example would be almost all of my services would have a health check on the auth service, because if I couldn't call the auth service, I could do nothing. And so I had that in there almost always, because the likelihood of me having a network problem of an individual box when I had thousands in my fleet to the health check service and not it being a holistic failure was quite high. That happened a lot more than I ever got my auth service to go down, except for that one time. Checking connection pool stats. So this is where, do you have live connections in your connection pool? Yes or no? If no, probably aren't healthy. Performing a query. You have to be careful here. This is where you're going out and doing something. You're actively doing it. Use caching, be careful. Database pools, for example, though, do this all of the time and they're really good at it. So look at the Hikari example, has really cool health checks into the drop wizard metrics. The one I wanted to call out though is this 99 percentile one. So they will actually emanate a health metric that says 99% of the time, all of people calling to get a connection under this threshold. And if that's not true, it fails the health check. And so that's an incredibly useful like way of looking at it. And like, I'm just nerding out over how much I like Hikari and Drop Wizard right now. So I will go back to this, but the link's in there. I will try to tell a very abbreviated story of an outage caused by not following these principles that I caused on myself. So I was in a rush and I wrote a health check against Cassandra that actively got a connection from its own connection pool, not a shared connection pool, and went and called what I thought was a trivial select one. But you couldn't do select one in Cassandra. I was like, I'll just call this system table that I know exists in everything. Turns out that is an uncached system table. It will always hit disk. And that was in our auth server. And remember how I said I always had my auth, like I would just always add auth server to all of my services. I caused an outage because as we added additional load balancers, because we were trying to solve a problem by adding load balancers and networking. I don't understand networking ever. And we were doing something weird with networking and subnets. So we ended up adding more load balancers. So all of those load balancers were checking the health check. All of the other services were also checking the health check. And that ended up putting so much strain on Cassandra that we caused an outage in our auth server
Oh my goodness.
because of health checks. We eventually figured it out and it was fixed because.
Tell them how many requests per second that auth cluster had to do though. It was insane volume.
By default, what was it? 1.5 thousand a second, I think.
1,500 calls per second.
I think so. Per
That's
region.
per region. Yeah, that's high.
That was out without, and that was excluding the health check. That was
Oh,
normal load. Because remember,
that's a lot, yeah.
we exclude health checks from monitoring. All right, that's all I've got. Sorry.
No, you're so good. This was so interesting. Does anyone have any questions they want to ask that are brief?
I will stay as long as people would like.
Yeah, I'll ask a question. So yeah, there are a lot of setups that people have where they might have, like I'm thinking of some stuff we have where there's like an ALB that's sitting in front of, like a custom proxy like Fabio or Trafic or, a, Kubernetes proxy or whatever. And then we've got, say like gRPC routing to a pod or whatever. Um, in these like sort of like layered situations, when you're debugging, how do you figure out if you detect that you think something's going on with the network stack, but like which one of these do you look at and what do you look for to decide what layer of like health checking is, you know what I mean?
So
Is down.
if you're doing a layered problem, I will always, I'm going to depend on the fact, I don't know if you have this, but if you do, and you can so if you're using an ALB, I know you can do this. You should have a custom header that you can set that will direct it to a single instance, a known instance. You should then do the health check with that special header to get a health check to that particular instance. If that works, you have a problem somewhere else, debug from there. But if it doesn't work, you now go on that instance and do the curl locally. If the health check works there, but not at the outside, now you can keep going in pairwise to each set. But in particular, you said ALBs. I would almost always have the special. There's a header you can set that will direct it to a particular instance with your path routing. The other thing you can do with ALBs is you can set up gRPC health checks at the target and different health checks at the target groups. And so you could check a
Yeah.
much more specific health check. But if I'm just generically, hey, I've layered a bunch of stuff, um, the question I would have is your health check being used by each thing along the way? Because likely the answer is yes. And so it's less likely that you have something end to end not working, and more likely that you have something where my middle proxy is reporting I have no healthy instances. And
Hmm.
thus you're looking at why is that? And if you don't have that and you're just passing health checks through, you should be not doing health checking at that middleware layer. You should almost just be like, I'm a straight proxy. I'm going to pass everything through and I'm going to do it all in the ALB with target groups. And that's where an ALB shines is like very complicated target groups. Other questions, anyone? Nope.
I actually do have one more. If
Yeah.
that's okay. So a lot of this is like we're talking about like at work or for something where we have like a lot of traffic. We have something big in production. What would your guidance be on like a personal project or like a small website? I feel like I struggle between like doing something for learning benefit and also then like I run into cost issues whenever I try to do something personally to like try it out.
So I
Yeah.
think it's kind of two flavors of this.
Okay.
One, are you doing this on Kubernetes? And if the answer is yes, the only way to make any of that work is to have health checks that work. You aren't going to make your pods actually like useful to your personal project without a health check. And doing that work is incredibly useful.
I was
The
on Kubernetes and did have all of my probes, but it was way too expensive. So I'm now on a digital ocean droplet and have no help with that.
So if it's because you're saying because you want to scale it to zero.
I think I want to practice best practices at a price that my wallet can pay for.
Yep. And so
Host yourself.
yeah, it's on-prem. The real answer on that one is on-prem. So what's happening, if anyone's not aware, is if you are setting up like a best practice health check to make sure something's alive, it will never be able to scale to zero cost for you on most of these elastic compute areas. And so if you're doing an active health check, which you should be in Kubernetes, it means you are not scaling to zero because scaling to zero means it's not there. And so that's where that trade-off is more around availability than it is anything else. Oh, is there questions in the chat? I didn't.
No, it's just more. Also, you're getting a lot of
Okay.
compliments. This was a really great presentation. And now this is like the third or fourth time that I need to run my cluster from home. So I think it's time to to start diving into that.
She has to run Nomad. She
So-
works at HashiCorp now. It's time.
If you're wondering, my setup that you saw was actually in VS Code was using the remote SSH into my Nook that is then doing a Docker dev container on the Nook. So it's actually all of that was running in the server rack in the other room. And it's a dev container inside of a remote SSH
Okay.
because I like making things too complicated. Nook is an old IBM NUC, next unit of computing. It was a cheap mini computer. There are AMD versions that are awesome that are cheap as well. Also, I'm addicted to RAM, so like when I say cheap, understand what I'm running is not what you would have to run to be useful. My Kubernetes cluster is also dual architecture, so it has both x86 and ARM64 in there because I haven't soldered my RISC board yet.
Okay. I am now going to, so thank you if anyone's watching on YouTube, but you are now getting cut off. We're going to take off the